So good evening all. So welcome to your second session of mass spectrometry. So in your first class of mass spectrometry, few points we discussed, such as what is the general introduction of mass spectrometry, what kind of sample is required, what is the physical state of sample. Then we also discussed about what is the general principle and applications. So what is the major applications of mass spectrometry? We can determine the molecular weight. We can determine the molecular formula. Small atoms, small fragments and carbon chain length, everything will be determined by mass spectrometry. That is an application, right? Then we learn general principle involved in mass spectrometry. So what is the general principle involved in mass spectrometry? When you take any sample in gaseous form that is bombarded with beam of electron, that may lose one electron and forms a radical cation. That is called molecular ion. Molecular ion undergo fragmentation, that is responsible to give variable small species, that is nothing but fragments. That process is called fragmentation. So generally we all discuss this one. Later on we introduce the term molecular ion. So what is the difference between molecular and molecular ion? Can you show some difference between molecular and molecular ion? Yeah, only one electron is differed by molecular and molecular ion. So the amount of energy required to remove one electron from any gaseous atom or molecule is nothing but ionization energy. Is it right? So we are spending some energy to remove one of the electron present in molecule. Similar to atom, molecule also having some energy to remove electron. So where electron present in molecule? In order to remove electron present in HOMO energy level. HOMO nothing but highly occupied molecular orbital. So generally how much amount of energy required to make ionization of any particular gaseous molecule into molecular ion? 7 to 15 electron volts generally. But initially we are applying 70 electron volts. But that much amount of energy not sufficient for generation of molecular ion. That is not sufficient means it is excess. So but what about remaining energy? Remaining energy utilized for fragmentation. So 70 electron volts helpful for generation of a molecular ion, then followed by fragmentation. Then two types of radicals we have discussed: even electron species, odd electron species. Even nothing but having even electrons in their total atom or total molecule. Odd electron nothing but carry odd number of electrons. Okay, so even electron is different, odd electron is different. Even electron ion is different, odd electron ion is different. So how to identify the positive charged ion in mass spectrometry? With the help of M/Z value. What is the meaning of M/Z? Mass by charge ratio. So with the help of mass and given by charge, means it may be a unipositive ion, doubly charged ion or triply charged ion or multiply charged ion, that will be divided by mass and that will give the M/Z value of a given fragment. And we know mass spectrometry is a 2D graph, right? It is a 2D graph between M/Z value versus percentage of intensity. So we are writing a short vertical lines in mass spectrometry. That short vertical lines are nothing but mass peaks. Whichever peak having a more intensity, that peak is nothing but a base peak, that peak having more stability. Clear? And very, very important thing, after formation of a molecular ion, try to remember this point. You try to confirm whether molecular ion is stable or unstable. If it is stable, less fragmentation, less information. If it is unstable, more fragmentation, more information. So every molecular ion, initially you need to confirm whether it is stable or unstable. If it is an unstable one, it is giving a more information to determine the structure. Is it helpful or not? Yes, see, if any molecule giving more fragmentation means it is giving more information. If you are getting more fragmentation, more information means you can determine the structure very easily and clearly. Okay, so between organic molecules and inorganic molecules in their gaseous state without losing electron, which is stable? See, what I am saying is, if you take any organic molecule or inorganic molecule in their vapor state, means I am taking organic molecule, inorganic molecule, initially they are having a different physical form, maybe liquid or solid, that I am converting into gaseous form. Later I want to remove one electron, right? So this process you need to apply both for inorganic as well as organic samples. Now the question is, between inorganic and organic samples, initially, which molecules are found to be stable? Organic is stable, right? When organic is stable, a beam of electron is going to come and collide with gaseous sample. They may lose one electron. Then forms unstable. Initially stable, then unstable, more fragmentation. But what about inorganic? Initially unstable, then it is stable. After once if they reach a stable form, they never undergo fragmentation easily and giving less information to generate a corresponding cation, radical, anion, radical cation, etc. Is it clear? So that's why mass spectrometry, specially it is introduced in organic syllabus but not in inorganic. So don't think that it is not belongs to inorganic. Inorganic coordination compounds also we can work out by using mass spectrometry. But why we are introducing mass spectrometry in organic? Because organic molecules will give unstable molecular ion. So what is our ultimate target? Whether unstable molecular ion or stable molecular ion? Unstable molecular ion. If molecular ion is unstable, what is the advantage? If molecular ion is unstable, it may undergo more fragmentation. More fragmentation means more information. See, if you are unstable, then only you will learn actively. If you are stable, can you learn actively? No. Means you are not interested. So similar to humans, even organic molecules also behaves in the same way. If it is unstable, undergo more fragmentation. Clear? So now, after molecular ion, now we are going to start types of electrons, how to generate a molecular ion, where to remove electron, to generate a radical cation. Clear? Right, keep reading. Types of electrons. How many types of electrons are present? How to remove that electron for getting a molecular ion? Types of electrons. If I take any organic molecule, most of the organic molecules having sigma pi non-bonding electrons. What is the meaning of non-bonding? Lone pairs. Okay, sigma electrons nothing but single bond, pi electron nothing but double bond or triple bond, and benzene. And here non-bonding electrons nothing but having a lone pair at least. Non-bonding means it is not involving in bonding. Generally most of the organic molecules having this kind of electrons. Organic molecules having sigma electrons, pi electrons as well as non-bonding electrons. So what about ionization energy order? Ionization energy order. Sigma electrons having high energy to required remove electron, followed by non-bonding electron, followed by pi electron in non-bonding. Means if I want to remove electron by using some amount of energy, I can remove easily from which one? Non-bonding. So which required high ionization energy? Sigma electrons. Sigma electrons required more amount of energy to remove as compared to pi and non-bonding. So finally one conclusion. Between sigma and pi electron, which electrons are very strongly bonded? Sigma electrons. Means if bond is very strong means ease of removal is not easy. Means we need to spend more amount of energy. That's why ionization order, sigma having high ionization potential as compared to pi, followed by non-bonding. Is it clear? Try to understand. From here onwards, concept is very, very important one. If you know this particular concept, types of electron, how to remove for a given organic molecule, first you can generate a molecular ion. Once if you generate molecular ion, then concept is very easy. You can easily understand what is homolytic fissions, heterolytic fissions, how to remove electron, how to generate a fragment, how to calculate implicit value. Everything will be very easy for you. Clear? So ionization order, sigma greater than pi greater than non-bonding. Then what about ease of C? Ease of removing electron. So how to remove? What is the ease of removing electron? Which is very easy to remove. Non-bonding electrons are very easy as compared to pi followed by sigma. Suppose if molecule having sigma and pi, from where you will remove electron? If molecule having sigma and pi, where you will remove electron? Pi. Suppose if sigma and non-bonding is there, non-bonding. If molecule having sigma pi non-bonding, If molecule having sigma pi non-bonding, from where we need to remove electron? Non-bonding. This is ease of removing electron. First priority give for non-bonding, then pi electron, then sigma. Clear? During electronic impact, based on the molecule, molecular ion formation changes. Molecular ion formation nothing but loss of one electron only, right? So now, first possible time taking. Molecules having only sigma electrons. So now I am taking a first example. So now take one example where molecule having only sigma electrons. See, this is methane. I am writing like this, CH4. Can I? In this, how many electrons are present between carbon and hydrogen? Between carbon and hydrogen, here 2 electrons, and here also 2 electrons. 2 and this is 2, right? Now, I am applying 7 to 15 electron volts of energy for generation of molecular ion or not? So, can I remove one electron from molecule or atom? Molecule. Now, try to remove electron from closer to carbon. Remove from here. Remove this electron. Remove this electron only. Don't remove this. Is this all sigma bonds are same? Is this sigma bond, this and this all are same or not? All are same. You can take any one. But always try to remove electron very close to carbon. If I remove electron, what is the charge experienced over here? Here carbon hydrogen, here carbon hydrogen, here carbon hydrogen. And what about here? Can I write positive charge? Here positive and here radical. Now here what about this? 2 electron and here 2 electron and here 2 electron. Try to understand. This is 2 center 2 electron bond. Between carbon and hydrogen, how many electrons are present? Between this carbon and this hydrogen, how many electrons are present? 2. How many centers are present? 2. This is one center, it is one more center. So I can say 2 center, 2 electron bond. And what about this? 2 centered, 2 electron bond. Here, 2 centered, 2 electron bond. And what about this one? How many centers are present between this side? 2 centers. But how many electrons are present? 1 electron. So now that electron belongs to which one? That electron belongs to which one? That electron shared by both carbon as well as hydrogen. Don't think it belongs to hydrogen. Once if you invested, that money is not yours. That money belongs to some other people. You are invested. Here also 2 electrons are present or not? If 2 electrons are available, these 2 electrons belongs to 2 elements. These 2 electrons don't think they are belongs to carbon, don't think they are belongs to hydrogen. Okay? So mutually they are sharing. 2 electrons belongs to carbon as well as hydrogen. Independently don't distribute that electrons to individual element. Clear? These 2 electrons belongs to carbon as well as hydrogen. If I remove one electron, which one is losing electron? Whether carbon or hydrogen? Which one is losing electron? Both losing electron. Don't think that carbon is losing. So if I remove one electron, how many electrons are present here? Only one electron. That one electron is keep moving between carbon and hydrogen like this. Means they want to share. One electron is removed, that's why written positive charge. So in your examination, remember they will write like this. They will write CH4 radical cation like this. This is a common symbol you need to practice. If they written like this, you need to know that where you removed electron. Where you removed electron in this molecule? Between carbon, hydrogen. Sometimes they will write a square symbol like this. See, this is CH4. Outside they will write radical cation like this. Like this also they will write. Both are same. So they may write like this. They may also write like this. Sometimes they may also write directly CH4 and here they will write one more time like this. All are correct. If they written like this, you are in a position to identify which one is losing electron. So normally you need to remember like this. This is a clear structure for you. When you write positive charge within the molecule, okay, don't write this outside representations. See, already a radical cation I written or not. So don't write this molecule like this. After writing radical cation, don't write like this. That is wrong. So in this I not written radical cation, right? So in this how many electrons are present? CH4 radical cation, how many electrons are present? How many? See, in CH4 how many electrons are present? 8 or 10? 10 electrons. So 2 electrons present in 1s2. 2 electrons present in 1s2. Remaining electrons present in 2s2, 2p. Total how many electrons? 10 electrons. Remove, don't consider that 1s2 electrons. Ignore 1s2. Then what about remaining electrons? 2s2, 2p. 2s2, 2p, right? In that 2s, 2p, how many electrons are there initially? 8. 2s, 2p carry 8 electrons. Generally, what is electronic configuration? 1s2, 2s2, 2p2, carbon. If you exit one electron, 1s, 2s1, 2p3. Every hydrogen give one electron. Here 4 and hydrogen 4, 8. Initially 1s2, 2 electrons. Total how many? Total 10. But outermost shell carry how many? 8 electrons. They are called HOMO. Is it clear? So consider 8 electrons. If I remove one electron, here how many electrons are present? Outside how many electrons are present? 7. So what is the meaning of writing 7 to 15 electron volts? I tend to remove one electron and forms a radical cation over here. So this carry 8 electrons. It is a 8 electron gaseous molecule. Now it is a 7 electron molecular ion. Whether I removed electron between two bonds, two bonded atoms or not. I removed one of the electron between two bonded atoms. Clear? So every time remember where we are removing. That is a key point. Don't write blindly. Try to concentrate where we are removing electron. Just listen one more. So here I am writing a carbon carbon, hydrogen hydrogen. See, between how many different sigma electrons are present here? 70 electron volts, or better you write 7 to 15 electron volts. See, in this how many types of sigma electrons are present? In this how many types of sigma electrons are present? Only one type. What are the type of sigma electrons here? Only CH type of sigma electrons are present. Only one type. But here two types of sigma electrons are there. Carbon carbon, and what is one more? Carbon hydrogen. These sigma electrons, and here see, this is carbon carbon sigma electrons. And what about here? Carbon hydrogen sigma electrons. Now these two sigma electrons are not same. Right? Don't think that all sigma electrons are same. Here only one type of sigma electrons are present. That's why I can remove any one of this electron from anywhere. Because all are same one type. Here two different types of sigma electrons are present. Carbon carbon one sigma electron, and here carbon hydrogen one more sigma electron. Now whichever having lowest ionization energy, that can lose electron easily. Which one? CC. Okay. So don't remove electron between carbon hydrogen. Always remove electron between carbon and carbon itself. This is having lowest ionization energy as compared to carbon hydrogen. Like this. I removed electron from here. This is having lowest ionization energy as compared to this one. So this molecule, how to write? How to write? See, this is C2. How many hydrogens? H6. Then can I write like this? This is radical cation. Okay, you can also write in one more way. See, this is C2H6 and this is radical cation. If I write like this, try to understand where I removed electron. Where I removed electron? Between two carbons or carbon hydrogen? Between two carbons. Like this you need to practice. Between this carbon carbon bond is there or not? Bond is there or not? Yes, bond is there. Don't think that, sir, here one electron is there, here positive charge is there. Whether bond is there or not, this question will come every time. 100% bond is there. Okay, you can write like this or like this. Better you practice like this only, because you came to know where you removed electron clearly. What is the first point? If all sigma electrons are same, you can remove electron from anywhere. If sigma electrons are differ, try to remove electron where ionization is very less. So between carbon, 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 hydrogen, which will carry lowest ionization energy? Carbon, carbon. So between these two, remove one of the electron, I remove this. I retain positive charge. And one of the electron left over here. That electron keep moving between these two carbons. So now this electron stabilizing two carbons means two centers and one electron. So I can say two center, one electron. So it is how many two centered one electron bonds are present? In this molecule, how many two center one electron bonds are present? Two center one electron bonds. In this, how many two center one electron bonds? One. This side. How many two center two electron bonds? Three. Here, how many two center two electron bonds? Two center two electron. Four. How many two centered one electron bonds? No. That is the difference between molecular ion and molecule. What is our ultimate target? Ultimate target is, our target is to generate a unstability. If it is unstable, then only it will undergo fragmentation. Then only you will get result. Suppose if your parents are not scolding you, you won't be activated. You won't be unstable. You will be stable only, continuously eating and sleeping in your house. You won't be activated. So if you want to get activation, some external pressure is required. Once if they provide some external pressure, you are going to get activated and you will undergo fragmentation. Fragmentation nothing but result. Right or not? So what is the requirement for any molecular ion? Unstability or stability? Unstability. Right. I will give one point here. You first write down these two directly. Right. Here you write one point. If molecule having CC and CH bonds, remove electron from, where you will remove? Remove electron from CC bond. If molecule having CC and CH bonds, CC and CH bond, try to remove electron from CC during electronic impact. Suppose if I take any straight chain, in straight chain, removal of electron takes place from terminal carbon carbon bond. Suppose if straight chain is present, try to remove electron from terminal carbon only. Don't try to remove from middle. In that, different CC carbons will come. Suppose this is CS3 and here CS3 and here one more CS3 I am writing now. So 7 to 15 electron volts electronic impact. What happens? See here how many different sigma bonds are present? Here only one type. Here two, carbon 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 hydrogen. Here carbon 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 hydrogen, but all carbon carbons are not same. This carbon carbon CS2 CS2, but what about this? CS3 CS2. CS3 CS2 sigma not same as compared to CS2 CS2. Now between carbon carbon bonds we are getting some difference. If carbon hydrogen carbon carbon both are present, we are giving priority for carbon carbon. Within the carbon carbon, if any competition comes, give priority for terminal. Is it terminal or not? So terminal carbon carbon can lose electron. So remove this electron from here. If I remove electron, then what is your answer? CS3 CS2 and here one more CS2, here plus radical CS3, like this. Right? Here I removed one electron. When you remove electron, don't put any bond here. Suppose if you want to put any bond, you can write like this. CS3 CS2 CS2 and this is CS3. Suppose if you put one bond here, write down like this. If I write like this, where I removed electron? At terminal, over here only. Here how many electrons are present? Initially 2, but right now if I write like this, meaning is this carbon loses one electron, here only one electron is present. Real structure is this one. In exam they won't give this structure, they will give this one only. So sometimes they may also write like this. So how many carbons? 4 carbons. How many hydrogens? 10 hydrogens or not. So they will write a square symbol and they will write radical cation like this. Clear? Right. So if any straight chain is given, always try to remove electron from terminal. Don't remove from middle. These points are most helpful from individual functional groups. In straight chain, removal of electron takes place from terminal carbon carbon bond. Is it clear? Right. Next. Similar point. Suppose if I take in branched chain, removal of electron, where it is takes place from branched carbon having bulky substitutions. They should carry bulky substitution. In any branched chain, branched chain, this is straight chain. Straight chain, no problem at all. Always terminal. But what about branched chain? If any branched chain is present, try to remove electron from branched carbon having More substitutions or bulky substitution. On that time, don't remove from terminal. Try to remove from bulky substitution. See, this is CH3, and here one more CH3 I am writing. Here hydrogen. Right side what I am writing? CH2, CH3. Is it a straight chain or branched chain? Seven to 15 electron volts. Is it straight chain or branched chain? Branched chain. This is called branched carbon. Suppose if this CH3 is not there, it is a straight chain. Like this. Okay. So, this is a branch carbon. This branch carbon carry methyl, hydrogen and ethyl. Right side ethyl or not? Which is a bulky substitution on this branched carbon. Ethyl is a bulky substitution. Now, don't remove electron from here. Generally, what is given here? In straight chain, try to remove electron from terminal carbon. But right now, if any branched carbon is present, try to remove electron from branched carbon having bulky substitution. Means don't remove from this side. Don't remove from above. Remove from right side. Right side 2 electrons are present. Always try to remove electron closer to branched carbon. Don't remove right side electron. Okay. So, you will get more stable carbocation like this. CH3 and here H, and this is positive. And here CH2 and here one more CH3 and this is dot. That is the answer. Okay. So, can I give like this? You can write CH and here one more CH3, and I can write CH2 and here one more CH3, and this is radical cation. Can I? See, if this molecule is given, after electronic impact, you will get this molecular ion. Like this they will give. So, can you say where it is loses electron? If they written like this, can you say where they loses electron? They losing from this carbon. So, you need to practice like this. Clear? This everyone can write. If you know this one, then you can write fragmentations. You will write fragmentations clearly. See, if you remove this electron, this carbon becomes carbocation or not? This carbocation is more stable as compared to right side. That's why try to remove from branched carbon. Is it clear? So, I will give an example. Try to generate a molecular ion, right? Based on these 4 points. See, this is CH3, 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 and this is CH3. 7 to 15 electron volts. Where you will create molecular ion? Neopentane. All are same? All are same. So, can I remove electron from right side or left side? Anywhere you can remove. Either this side, any side you can remove. Suppose if I remove electron from one of the branched carbon, can I write positive here? Positive. And what is this? Radical. Can I? Then how to write this molecule? CH3 carbon, and here one more CH3, CH3, write CH3. Can I write like this? Is it clear? Is it easy? Now see one more example. Try to understand clearly. This is methyl, and here I am writing ethyl, CH3. Then here I am writing isopropyl, CH, CH3, and here one more CH3, and here I am writing hydrogen. Now, if you understand the concept, you can give the answer. 7 to 15 electron volts. So, where you will generate molecular ion? Isopropyl. Can I generate from below? This or not? See, this carbon, hydrogen is there. This carbon also, hydrogen. So, this is isopropyl for this one or not? See, this carbon, above ethyl, left side methyl, below isopropyl. Here, how many electrons are present between these two? 2. Remove this electron. If I remove this, it is a more branched carbon or not? CH3H, and this is positive and this is radical. This is CH, CH3, and here one more CH3, like this. Suppose if you want to write molecular ion for this one, simply put like this. This is a real way of representing. In your exam, they will write like this only if they want to ask any question. But really, if you practice like this, your answer is clear. This is molecule and this is molecular ion. If molecule having branched carbon, if any straight chain or branched chain both are given, remember, if any straight chain is given, try to remove electron from terminal carbon. If any branched chain is given, try to remove electron from branched carbon having bulky substitutions. Why? Why we are removing from bulky substitution? That questions you need to ask. Because if I remove electron from branched carbon having bulky substitution, that will give stable carbocation. Here you will get stable carbocation or not? If this is stable, this is unstable or not? If this is more stable means, and what about this one? More unstable. Then we can break them very easily. Clear? I am not saying that this molecular ion is more stable. What I am saying is, whenever if you remove one of the electron from branch carbon, you will get a cation. This cation is stable, highly stable, and radical is highly unstable. If cation is highly unstable, radical is highly unstable means we can break that bond very easily. What is our intention? Our intention is to break molecular ion into pieces. Right or not? More unstable means more fragmentation. Suppose see, one person take a pot and he want to drop from a first floor. Then second floor, third floor, same experiment repeat for 4th, 5th, 6th, 7th, 8th, 24 floors, which is unstable. So you are standing on a 24th floor and you are holding a pot to break them into small pieces and you want to drop that pot on ground floor. First of all, you are stable or unstable? First of all, you are unstable. So whenever if you are standing on a first floor with a pot, you become a little bit stable. If you are stable, releasing is comfortable. If you are unstable, unstably, it might be more damage. Clear? Are you able to understand? Is it class is fast? Is it okay? These basics are very, very helpful for mass spectrometry. Remember, if you unable to understand basics in mass spectrometry, it is impossible to enter into the concepts. They are very, very important basics. You need to know from where we need to break. After generation of molecular ion, if you don't know where to break, it is no use. Right? Then say this. Right. In cycloalkane, removal of electron, where it is takes place? Removal of electron takes place from carbon-carbon bond. Cycloalkane I am saying. What are cycloalkanes? Can I take 6-membered is a cycloalkane? Now here how many types of bonds are present? How many types of sigma bonds are present? CC and CH or not? Is it CC or all are same? In this molecule CC, all are same? All are same. No need to hesitate. You need to change your expressions. I am not asking a typical question. This carbon-carbon, this carbon-carbon, every carbon-carbon bonds are same. Right? So, if I apply 70 electron volts, initially I required 7 to 15 electron volts to remove 1 electron. So, from where should I remove electron? Between carbon-hydrogen, between carbon-carbon. Carbon-carbon. Which carbon-carbon? Any one. I can remove this carbon, electron, this carbon, anywhere I can remove. Suppose if I remove electron from here. See, this is a 6-membered ring. I am removing electron from here. Here I am removing. Here how many electrons are present? 2. If I remove one of the electron from here, then what is the charge? Here it is positive and what is this? So is there any bond is present between the two carbons? Yes. Remember, don't think it is no bond structure. You should write like this. That is the meaning. I can write like this. Clear? Otherwise enclosed in box, you can represent the structure. Right or not? Suppose if I take any 5-membered ring. See, this is 5-membered ring. 7 to 15 electron volts. Can I write like this? Where I removed electron? Between two carbons. So you can also write in one more way. You can enclose in box, then write down radical cation. Like this also you can write. All 3-membered ring, 4-membered ring, 5-membered ring, 6, 7, 8, 9, 10, whatever it may be the cycloalkane. Always try to remove electron between two carbons only. Don't remove from carbon, hydrogen. Write parallelly. While I am writing point on board, if you write parallelly, it becomes very easy for you. It looks pleasant to listen. Otherwise, while I am writing any point on board, if you listen blindly, on the time, I will enter over here. Then you are start writing this point. You won't understood the concept. If I am writing any point on board, keep your mind and write down with your proper knowledge on concept directly on your notes. If any additional point is required, you frame directly. That is the art of learning organic chemistry. That is the best way to learn chemistry. So two things are working. You are focusing on the concept, your mind is listening the words what I am saying. You are understanding clearly. And by reading that points also you can understand second time those who not understood. By reading that points you can understand the points. Okay? Then by watching these points directly you can get more clarity. Clear? Suppose in alkyl cycloalkane, removal of electron takes place from ring substituted carbon. What do you understand with this statement? In cycloalkane, removal of electron takes place from carbon-carbon bond. It is easy? Yes, directly you can attempt. But what I am saying is, in alkyl cycloalkane, what is that molecule? Can you guess? Alkyl cycloalkane. Means if I substitute one group here, methyl, ethyl, isopropyl, anywhere on this 6-membered, 5-membered, 4-membered, 3-membered, etc. On the time from where you will remove electron. That is the question. In alkyl cycloalkane, removal of electron takes place from ring substituted carbon. Okay, so try to understand. This is methyl. Methyl is substituted on this ring. Okay, so now I am applying 7 to 15 electron volts. Then where should I remove? It is a ring substituted carbon or not? Ring carbon, everywhere ring carbon, but this ring carbon carries substitution. So try to remove this electron only. Ring substituted carbon will lose electron. So if I remove electron, can I write positive charge outside or inside? Always write positive charge inside. Don't write outside. So you may also ask one question, sir, why you are writing positive charge over here? Why not above? Why not radical below? Because if cation is stable, radical also stable. If cation is stable, radical is unstable. Highly unstable. Two possibilities I am saying now. If I write cation here, this ring is stable, then radical is unstable. So this you can also write like this. See this. You write methyl and write down radical cation like this. So if I given this molecule 7 to 15 electron volts, if I mention 7 to 15 electron volts, try to remove electron from here only. Clear? So that is your first type of example where molecule having only sigma electrons. Right? Next, second possibility. Molecules having sigma and pi electrons. So what happens when molecules having sigma and pi? From where we can generate molecular ion? Can you give an example having sigma and pi? So which is easy to remove? Pi or sigma? Pi. See, carbon-carbon double bond is present. CH2 and here also CH2. If I apply 7 to 15 electron volts, so where should I remove electron? See, is it a pi electron? It is a pi electron. What about below? This was sigma electron. So don't remove from sigma, remove from pi. If I remove this electron, this carbon carry positive charge. Here it is radical as it is. This is the answer. So this you can also write like this. CH2 carbon-carbon double bond. This is radical cation. If I given this molecule, if you want to generate molecular ion, remove electron from pi bond. Don't remove from sigma. Okay. Suppose if I take triple bond, carbon-carbon triple bond, 7 to 15 electron volts. So can I remove from one of the triple bonded carbon or not? Here this is radical and this is cation. You can remove either from right side or left side. Anything is possible because it is symmetric. If I remove this, what is your answer? Carbon-carbon triple bond H and this is radical cation. Suppose if I take benzene having pi bond as well as sigma bond, so 7 to 15 electron volts. So can I remove one of the electron from here? Remove this electron and you will get this one, double bond and positive and radical. Right? Anywhere you can remove. Remove either this electron like this, anywhere. Carbon, carbon. How many double bonds are present? 2 double bonds are present. So where should I remove electron? Pi electrons are not. So remove from inside. Remove from inside. If I remove from inside, you will get like this. This is CH, sigma bond, and this double bond is unaffected. And what is this? This is radical and this is double bond. So how to write this molecule clearly? I can write like this or not, as it is. Put a conjugate double bond and write reverse radical cation. So if I given a diene, conjugate diene, always try to remove electron from inside. Don't remove from outside. Clear? Because cation stabilized by conjugation. See, this double bond is conjugate to this cation. That's why try to remove from inside. If I write molecular ion like this, where I removed? Whether I removed sigma bond or pi electron? Pi electron. Now that pi electron is inside carbon, not from terminal. Is it clear? Now I am giving a carbon-carbon double bond and triple bond. 7 to 15 electron volts, where you will remove electron. Between double bond and triple bond, which is easy to remove electron? From double bond we can remove electron easily as compared to triple bond. So here 2 electrons are present, here also 2 electrons are present. Remove electron from double bond when triple bond is competites with double bond. Because here electronegativity is a factor. What is the vibration of triple bond? Sp. What about double bond? Sp2. It is more electronegative, less electronegative. Easy to remove, not easy to remove. Okay? So I can write like this. This is CH, carbon-carbon triple bond hydrogen, and this is radical and this is cation. Clear? Next, third possibility. Molecules having sigma and non-bonding electrons. Third possibility. This is a case where you will find sigma electrons and non-bonding electrons both are available. Molecules having Sigma and non-bonding. Can you give an example? Alkyl halide, C. CH3CH2 and this is bromine. Here one lone pair, and this is lone pair. 7 to 15 electron volts. Then what is the answer? Where you will remove? Here sigma bond is there or not? And non-bonding electrons also present on halogen. So remove one of the electron from out of 3 lone pairs. Any one you can remove. So if I remove this, what is the answer? Here bromine, radical cation, lone pair. So this you can write like this. CH3CH2 Br radical cation. Alkyl halides, and one more example is alcohols. You know, CH3CH2 and this is OH. Here how many lone pairs are present? 2 lone pairs. So remove one of the electron from one of the lone pair. So radical cation, hydrogen, and this lone pair as it is. This can be written like this: CH3CH2 OH radical cation. Alcohol. Only sigma non-bonding or not? Yes, only sigma non-bonding. And if I take any ether, ether is example for this family. Can you give the answer? Ether. Then can you give one more example? Amine. You know amines? Amines. This is primary amine. I can give secondary amine even. What is the difference between primary and secondary amine? Nitrogen having 1 hydrogen here. Here 2 hydrogen. So can I take tertiary amine? What about tertiary amine? Nitrogen having lone pair, no hydrogen. So same way, 7 to 15 electron volts generate molecular ion. Can I remove from here? 2 lone pairs are there, remove electron from here. Put radical cation, that is your answer. Remove 1 electron. Remove 1 electron. Remove 1 more electron. Everywhere same. Will you write the answer? After removing electron, put cation. That's it. So where you will remove electron? C. What is the name of these heterocycle rings? Tetrahydrofuran. If I write double bonds here, that becomes a furan. It is a reduction product of furan, also called THF. So universal organic solvent THF, tetrahydrofuran. It is one of the best organic solvent. If I say universal solvent, that is THF only. Most commonly available solvent, easily extracted from variable sources. So this is commercially available solvent, THF. So where you will generate radical cation. This is called pipyridine. Pyridine comes from pyridine, pipyridine. Then what is this? If I write double bond, that is pyrrole. Then pyrrolidine. So here hydrogen, here radical cation, like that. Now this is one more example. Molecules having sigma pi non-bonding electrons. 3 possibilities. Can you give an example? They have sigma, they have pi, they are also having non-bonding. See in this any pi electron? Third example what I given. If you observe anywhere pi electron is available? No pi electron, only sigma and non-bonding. See, this is sigma bond, this is non-bonding. Sigma bond, non-bonding. Here non-bonding, and here also sigma non-bonding. Last examples all are sigma bond and non-bonding. There is no pi bond. But right now, what I am saying, not only sigma non-bonding, also pi electrons are available. So best example is vinyl alcohol. This is called vinyl alcohol. This is vinyl alcohol. See what is this bond? Sigma, and here pi. And what is this? Non-bonding. 3 is present or not? So if I apply 7 to 15 electron volts of energy, which one is going to remove electron? Oxygen or not? If oxygen loses 1 electron, forms this. So when this molecule is given in exam, they will give like this only. This is OH, here lone pair, here radical cation. They will give 2 electrons here, like this only they will give, but don't think that electron is present. Actually it is a molecular ion. Clear? If they given this molecule, by applying 7 to 15 electron volts, you need to write like this. Otherwise, you write like this. Don't think that here 2 lone pairs are present. How many lone pairs are present in this one? 2 lone pairs. Here how many lone pairs? One lone pair. Here how many lone pair? One lone pair only, not two lone pairs. So you can also go through conjugate halide like this. 7 to 15 electron volts, and even amine also we can take. See, sigma pi, and what is this? Non-bonding. And here also sigma pi, non-bonding. You know chlorobenzene? Chlorobenzene. Here how many types of electrons are present? See, here can I remove electron from chlorine or not? Remove electron from chlorine, put radical cation. Here also radical cation. Can I remove from nitrogen? Remove this. Clear? Here what should I write? CH2, CH, CH2, nitrogen H2, and here radical cation. Now positive charge is present on which one? Nitrogen. Clear? In this one. I removed electron from non-bonding or not? Yes. Now in this case, see, here this is pi electron, here sigma electron, and what is this? Non-bonding. So can I remove electron from chlorine? Yes. Remove electron from chlorine, you will get radical cation like this, chlorine. You know phenol? What about phenol? This is OH. So where you remove electron? From oxygen or not? So in your exam, see, normally they will represent like this. They will give OH and they will write radical cation outside. Like this they will give. Where I removed actually? Can I remove from oxygen or not? Which lone pair? Any lone pair you can remove. Phenol, it is an example of sigma pi non-bonding. There is a prions of sigma, there is a prions of pi. This is pi, this is sigma, and this is pi, and this is non-bonding. Right now I am taking aniline, aminobenzene, aniline. Can I remove electron from nitrogen or not? If I remove electron from nitrogen, I will get, that is NH2 radical cation like this. See here, carbon nitrogen triple bond is present. So where you will remove electron? Cyanobenzene. From double bond or triple bond or from nitrogen? From nitrogen. Because nitrogen having one lone pair. A nitrogen radical cation like this, right? Suppose if molecule having CH3 C double bond O and this is OH, here 4 lone pair of electrons are present, 7 to 15 electron volt. So from where you will remove electron? Be careful with this. Will you remove electron from OH or oxygen? Which one you will remove? So try to remove from unsaturated. Is this oxygen is having double bond or not? Is this oxygen having double bond? No. This is unsaturated and this is saturated. So try to remove electron from unsaturated oxygen. That is a predominant one. So if you remove electron from unsaturated oxygen, this oxygen is high electronegative. High electronegative. It can repel this electron very fastly. High electronegative element unstable with electron. That's why it will push us this electron effectively. That's why it is unstable. So what is our target? To generate more stable molecular ion or unstable molecular ion? Unstable. So try to remove from here only. This is predominant. Remember, suppose if these molecules are 100 is there. 100 these molecules are there. In 100 molecules, nearly more than 80 molecules will give this kind of molecular ion formation. Nearly 10% of molecule will give this kind of molecular ion. This is unstable. This is unstable or not? Now one more, you will get stable. This is little bit stable. This is only 10%. 2 molecular ions are possible. But whichever is major, that is a predominant molecular ion. Don't fix for only one kind of molecular ions. 100, suppose if only one molecule is there, directly over here. Suppose if any possible number of molecules, n number of molecules are available, in that how maximum molecules are losing electron, from where they are losing electron, that is a predominant molecular ion formation. Molecular ion formations may be varies, changes. See, when beam of electrons are coming for a molecules of acetic acid, nearly 100 molecules are there in one particular sample. If any electrons are coming and they are colliding directly, there is a possibility of losing this electron also, but less possibility. Okay, but predominant is this one, where unsaturated oxygen, always unsaturated oxygen, unsaturated nitrogen is predominant. Clear? But this is different. See, this is double bond O and here anion. If any negative charge is given, remember, here I am writing 3 lone pair of electrons and here I am writing 2 lone pair of electrons. What is the difference between this and this? This is generally represented like this. This is acetate ion. Acetate ion means CH3 double bond O. Here this is lone pair and here also lone pair. And see, here I can write negative charge here. This and this both are same. When acetic acid, after losing proton, they will form like this. When acetic acid loses proton, you will get this one. So writing negative charge indicates that this oxygen carry how many lone pairs? 3 lone pairs, not 2 lone pairs. Okay, then what is this? It is a neutral. And what is this? Positive or negative? Negative. When neutral negative competition comes, give priority for negative. For losing electron from gaseous molecule to form molecular ion. Is it clear? So, if I apply 70 electron volts or 7 to 15 electron volts. Then what is your strategy? Can I remove electron from here? How many lone pairs present here? 3 lone pairs. If 3 lone pairs are present, now I am writing double bond. This lone pair I am not disturbing. This lone pair is available. This is radical and this is cation. Clear? Like that we should write. This is radical and this is cation. Sometime positive charge will be disappear to attain stability, right? So out of 3 lone pairs, 1 lone pair, 1 electron is removed. So you can write radical cation like this. So observe clearly, it is not a correct way of writing. Why? Because, see, this lone pair belongs to oxygen. Yes, this lone pair belongs to oxygen. Is this lone pair initially belongs to oxygen? No. Actually, out of these 2 electrons, which electron belongs to oxygen? This electron belongs to oxygen. And what about this electron? This electron coming from which one? You observe this carefully. Here how many lone pairs are present on this oxygen? 2 lone pairs. And here also 2 lone pairs. When here already 1 electron is there or not? Which electron that one? Oxygen or hydrogen? Oxygen. Now here 1 more electron is there. If I remove this hydrogen in the form of H+, this electron added here. This electron become lone pair or not? But actually this electron belongs to oxygen, and what about this one? Hydrogen. Means 1 extra electron I am removing or not? Here how many electrons are there? Total 6 electrons or not? So out of these 6 electrons, 1, 2, 3, 4. These 2 lone pairs belongs to oxygen. Out of these 2 electrons, either 2 electrons belongs to oxygen or only 1 is belongs to oxygen. Initially 1 electron belongs to oxygen. 1 more electron, extra electron, coming from which one? Hydrogen. That's why it is called -1. Means that extra electron I am removing. If I remove this extra electron, can I write with neutral or not? So don't write positive charge. Remember, write down in the form of lone pair, radical. This is the correct structure of this one. This is not a correct structure. But one of the lone pair we removed. But that we removed from added electron, not its own electron. See, in your pocket 1 rupee coin is there. So whenever if you are walking on a main road, you find 1 more additional coin. 1 more 1 rupee coin on a main road. So you simply taken that 1 rupee coin and you are added in your pocket. Then how many rupees you have? How many rupees you have? 2 rupees or 1 rupee? 2 rupees. Whether 2 rupees are belongs to you? Actually, how many rupees are belongs to you? Only 1 rupee. Then what about this 1 extra? This is gain, additional, extra. Suppose after moving some distance, you found that only 1 rupee is there in your coin suddenly. So finally my question is whether you are a loser or gainer. Initial, final stage I am saying. Initially how many rupees you have? 1 rupee. After some time, 1 extra rupee got in your pocket. Later after some time, you lose that 1 rupee. Then finally how many you got? How many you have in your pocket? Initially 1 rupee. I got 1 extra 1 rupee on main road. After some time I lose that 1 rupee. Then how many coins are there in your rupee, in your pocket? 1. Whether you are loser or gainer finally? Huh? Neutral. You are neither loser, neither gainer. Same way. This one, same. That's why don't write positive. What is the meaning of positive? Loser. What is the meaning of negative? Gainer. Gaining means negative, loser means positive. But see, actually you lost electron, but finally you not your electron. Whatever you gain, that you lost. You got one extra rupee, that you lost. Will you feel happy or unhappy? Stable. So after getting 1 rupee, you feel little bit happy. Then after losing one more rupee, you will find that okay, nothing will happen. Just now I got that one extra, now it will lose. Nothing will happen. Okay. So you are not loser. Finally I am saying is, you are not a loser. When you are loser, initially you have 1 rupee. After some distance, if you found that 1 rupee is not there in your pocket, then you are a loser. Then write plus 1. You lost 2 rupees, plus 2. You lost 3 rupees, plus 3, like that is the meaning. If you are writing plus 1 means molecule losing its own electron. If you not write plus 1, which means you are not losing your own electron, but you are losing. Remember, here see, if I apply 7 to 15 electron volts to this molecule, 1 electron is removed, but you need to write like this only, don't write like this. It is not a correct way of representing. But 1 electron is removed. Try to understand. 1 electron is removed, but that electron is not belongs to its own. That electron gained by some other element. It is not its own electron. So you will write positive charge only when if you remove electron from its own, in your own pocket. Suppose you are earning some money. Okay, so monthly salary 20,000 you have. After 1 month, so you got 20,000 salary in your account, distributed in your account. So that is which one? Is it your own money? That is your own money or not? Yes, that is your 1 month salary money. So in that if I remove 1,000 rupees, is it plus or minus? Plus only. 2,000 rupee plus 2 means that is your own money. No one should remove in that one. If anybody is removing from your own money, you become deficient. Suppose your salary is 20,000. Your parent deposited 1,000 rupees in your account. Total how much? 20,000 and 1,000. Total how much? 21. Okay. So after few days, your father is saying that he needs some money. Try to send 1,000. You transferred 1 more 1,000 to your parent. Then whether you are loser or gainer? Neutral. He was deposited. Finally, he was taken to 1,000. So finally you write neutral. You are neither gainer, neither loser. On that time, don't write any charge. Here also same. I am not writing any charge. But whether it is losing or not. From here to here, electron is losing or not? Yes. This is important one. Generally, most of the people, they will think very easy to remove electron, but it is looks complicated if you not understood clearly. Okay. So here remember nitrobenzene I am giving. This is nitrogen, double bond. Here it is -1. Here this is plus. 7 to 15 electron volts. Where you will remove electron? In this molecule, how many lone pairs are present? Nitrobenzene carry how many lone pairs? In this, how many lone pairs are present? In this, how many lone pairs are present? How many lone pairs present in this molecule? 3 or 5? 5. -1 means 1 extra lone pair. Here 3. 3 plus 2, 5. In this, how many? 4. In this, how many lone pairs? Nitrogen having no lone pair. Positive charge already given. Nitrobenzene, what is the charge? NO2 neutral. But really, nitrogen carry positive, one of the oxygen carry negative. Here, how many lone pairs are there? Here, 2 lone pair. Here, 3. Total, how many? 5. Now, I want to remove an electron. What is the charge should I write? Where should I write? Can I remove electron from pi? Here pi electrons are present in this one. Sigma electrons, pi electrons, all are present. This is pi electron, this is sigma electron, this is non-bonding, here also non-bonding, here non-bonding, here negative, negative nothing but non-bonding only. Okay, so they carry non-bonding, negative and pi electron, sigma, all electrons are present. So where should I remove electron? Can I remove from minus? Yes. When minus is there, remove from minus. When neutral is there, remove from neutral. When positive is there, that is least priority. First give priority for negative, then neutral, then positive. Negative charge can lose electron very easily compared to neutral. This is neutral, this is neutral, this is negative. Negative can lose electron easily. Suppose negative, neutral, positive is given. What is the order? Negative, neutral, positive. Suppose here positive, neutral both are given. Neutral, try to remove electron from neutral. When positive charge is present, attraction force is very high, not easy to remove. More ionization energy is required. So, here this oxygen carry how many lone pairs? 2 lone pairs or 3 initially? This oxygen carry. Here this is 1 lone pair. Here can I write positive charge? Now here initially carry how many lone pairs? 3 lone pair. In that 3 lone pair, 1 electron I removed or not? How many electrons are left? 1 electron. Can I write positive charge here? On this oxygen, how many lone pairs are there? 3 or not? 3. O minus means 3 lone pair. So, out of 3 lone pairs, this is 3 lone pair. I removed 1 electron from here. Now my question is, can I write positive charge on that oxygen or not? No. Why? Minus 1 is what? What is the meaning of minus 1? Gain extra electron. That extra electron we removed. Then it becomes neutral. Minus 1 means how many extra electrons? 1 extra. If you remove 1 extra electron, neutral. Then remove 1 more electron, then positive. If you want to get positive, remove from neutral. Try to understand. I think it is something entered but not clear, I think so. Is it clear? Just write down. This is radical cation. Remember, it is a radical cation. And what is this? Is it a molecular ion? Yes. Is it molecular ion? No. It is not molecular ion. Here can I write dot and plus? Yes, dot and plus you can write. Because dot and plus both are available. But can you write dot and plus here? No, don't write plus here. Plus is not present. This you can write dot and plus, but don't write dot and plus on this one. Clear? Is it clear how to generate molecular ion? See, this is O minus 1. Phenoxide, you know, phenoxide. Phenoxide. 7 to 15 electron volts. I want to remove electron from phenoxide ion. What will be the molecular ion? If phenoxide ion is a parent, then what is a molecular ion? Radical. Write down the structure of that molecular ion. This is molecular or not? What is the molecular ion of this one? Write down. Don't see my face. You try to attempt. Whatever you are understanding, try to attempt. You people think that everywhere dot and radical is there. Dot and plus, that is why sir is taking this much of time to write dot and plus. That dot and plus is not molecular ion. every time. Most of the cases that is a molecular ion, but not every time. So what is the molecular ion of this one? Very good. This is 2 lone pair plus 1 radical. This is molecular ion. CH3 double bond O and here H and here H and I retain positive. Now 7 to 15 electron volts. So where should I remove electron? If this is a molecule, what is its molecular ion? Now here one lone pair is there or not? Here how many lone pairs on this oxygen? 1 lone pair. Here how many lone pair? 2 lone pair. Where you will remove electron? 2 lone pair. When positive neutral competition comes, neutral. So if I remove electron from neutral, can I get this? This is OHH and this is positive. Here one lone pair asterisks, here one radical and this is cation. Now say what is molecular ion? Who is molecular ion? Is it radical cation always molecular ion? Is it a cation? Only radical. Here initially cation. If this cation loses 1 electron, then what you get? Radical dication. Is it radical or not? Radical, how many cations are there? 2. Radical dication. That is also molecular ion. Only radical cation is not molecular ion. Generally you will think that if you remove, this is radical cation every time. Dot n plus is mandatory. That you will think. That you will fix. That is not molecular ion. Molecular ion is that one which will lose 1 electron from parent. From parent, if they lose 1 electron, that becomes a molecular ion. During electronic impact, we are passing electron beam and we are removing from 1 electron for a given molecule. Is it clear? Suppose, listen, I am taking sodium. Sodium is a metal. Is it metal loses 1 electron? Yes. If sodium loses 1 electron, then what you will get? Is it positive charge directly or can I write radical cation? Sodium belongs to which group element? First A group element. How many electrons they can lose? 1. So write down positive. Now what is this? Don't write radical cation now. I am writing only Na plus. Then what is this? Molecular ion. If this is a vapor phase, sodium is in vapor phase. If you remove 1 electron from that molecule, that becomes a molecular ion. Now who is molecular ion every time? Is it a radical cation is molecular ion? Or only radical is a molecular ion? Radical dication is a molecular ion? Or only cation is a molecular ion? Anyone is a molecular ion. Remember, don't think that only radical cation is molecular ion. Anything is a molecular ion, but condition is they should lose 1 electron when you impact a electron. Clear? So don't think that radical cation is every time molecular ion. Okay? Suppose, just try to understand, calcium plus 1 I given. This is parent. 7 to 15 electron volts. Calcium I introduced in sample tube in mass spectrometry. Calcium plus 1, initially calcium plus 1. When electron beam is colliding with this sample, it will loses 1 electron. Right? Then what should I write? Calcium plus 2. Then who is molecular ion here? Calcium plus 2 is a molecular ion. This is molecular ion. Commonly, how you will write molecular ion? You will write molecular ion like this. This is applicable for organic samples, only few molecules only, not for all. In your textbooks also they will write like this, but that is not correct. Clear? Suppose if I write aluminium plus 2. Now I want to remove one electron. Then what happens? Aluminium becomes plus 3. Who is molecular ion? Plus 3. Suppose if I take chlorine carry 3 lone pair, 1 extra electron. Now 7 to 15 electron volts. I want to remove one electron. Then chlorine carry how many electrons? 7. If I remove this electron, then chlorine become lone pair, 1 electron loosed, positive. Now, is it radical cation? No, it is not radical cation, only cation. Is it radical cation? No, only cation. Is it radical cation? Only dication, trication, cation. What is this? Cation. Now, between these two, who is molecular ion? This is molecular ion. Suppose, just listen. If I write chlorine minus 1, 7 to 15 electron volts, then remove this. Chlorine minus 1. What is the molecular ion of chlorine minus 1? What is the molecular ion of chlorine minus 1? Chlorine radical. Very good. Chlorine radical is a molecular ion. In this, how many lone pairs are present? Cl minus 1. 1, 2, 3, 4 or not? Initially, how many electrons I carry? 7. 1 extra. This is extra, minus 1. If I remove this one, then chlorine carry 1, 2, 3, and this is extra. Chlorine radical is a molecular ion of chloride ion. Chlorine radical is a molecular ion or molecular species. Ion means generally they should carry positive or negative. That is not mandatory. Generally, orally they will say molecular ion for organic molecules. But mass spectrometry can identify only which one? Positive ions. Is it positive? No, it can't be identified. We removed one electron, but not possible to identify because it is not a positive ion. Only positive ions can be identified by mass spectrometry. Suppose O minus 2 is given. 7 to 15 electron volts. If I remove one electron, what is that? O minus 1. O minus 1 is a molecular ion of which one? O minus 2 lose or gain electron? Lose electron becomes minus 1. Suppose, remember, O minus 1, same 7 to 15 electron volts, I written this one. Then can I write radical? Then what is this? O minus 1 is a molecular ion of O minus 2. Oxygen radical is a molecular ion of O minus 1. Don't say molecular ion, molecular species. Actually, real name is molecular species. Indian authors generally they are termed as molecular ion. That is wrong. Molecular ion, you can say only that one which will develop the ion. But every time you will not get molecular ion. You will get molecular species. Molecular species is a correct word. Okay. Suppose if I take this molecule O, lone pair, 1 extra electron. Now 7 to 15 electron volts. Then now will you get positive charge? Here lone pair, can I write positive? Yes, positive. Now what is this? O plus is a molecular species or molecular ion. Is it ion or not? You will get positive. When you get positive, negative, then say ion. If you are not getting positive, negative, if you are getting radical, you will radical or neutral, say species. Even positive also you can say species, but generally in fast you will say molecular ion. It is a molecular ion of O radical. So they will ask like that. What is the molecular ion of this O radical? Molecular ion of this O radical. O minus 1 is a molecular ion. This is the molecular ion whose source is this one. Right. Clear? So that is about generation of molecular ions in total organic and inorganic molecules. Now you people are very strong in generation of molecular ion from a given molecule, I think so. Right? So in your next class I will explain what is the stability of a molecular ion, how to stabilize. What are the general probabilities are there for stabilizing a molecular ion. If different hydrocarbons are given, different branches are given, different molecular weights are given, different conjugations, functional groups and aromatic skeletons and the rings and open chain, everything will be discussed in your next class. Okay, we'll stop here and we will continue in your next class. Okay, we'll stop here. Are you learn something new? Or any common thing what you learn in your PG, same thing you learn. So uncomparable, they won't explain this all things. Even if I go as a faculty for your PG, even I went as a professor, assistant professor for variable colleges to teach mass spectrometry NMR like that, I won't explain this all things. Student has to learn. Student has to think. Spoon feeding they won't give. You need to think and you need to analyze. But here it is coaching centers, no other alternative. Some spoon feeding is required. Core knowledge, core analysis is required to attempt CSR questions. Okay, we'll stop here.